How can a man move a box horizontally if, as Newton's third law predicts, the push of the man on the box equals the push of the box on man? So if you were to look at the question carefully, here the question is asking how can a man move a box? So the focus should be on the box because you want the box to move. So what we need to consider will be the free body diagram for the box. Consider forces on the box. I will have the force F. This is the force by man on box. So I'm going to call this F with a subscript Bn, by man on box. Then what other forces act on the box? Okay, there is a contact between the box and the ground, so there will be friction. The direction of friction is to oppose the motion. Since the man is pushing the box to the right, friction will be to the left. So there is a friction here. Okay, so small f will be the friction between the ground and the box. So these are the two forces acting on the box. So how can the box move? In the forward direction, that is to the right. The box will only move if and only if the force by man on box is greater than friction. Okay, so the box will still move. So this is how you can write it. When force by man on box is greater than friction between the ground and the box will move. Now let's come back to the question on Newton's third law. So this statement here, the push of the man on box equals the push of the box on man. Is this statement correct? Yes, this statement is correct, but it's acting on two different bodies. Okay, so there will be a force by man on box. Similarly, according to Newton's third law, the man will also experience a force that is by box on man. So these two forces are equal in magnitude but opposite in direction. But that force, which is the force by box on man, does not act in the box. Okay, that's why when you consider the box, you don't need to look at this force, which is by the box on the man. You just look at the force on the box, namely this pushing force as well as the friction.